Hello students, welcome to another video on chemistry for class 8. We are discussing the chapter atomic structure. Today I am going to tell you about two important concepts, that is valency and isotopes. So let us begin. So what are isotopes? You know that the atomic number and atomic mass of the various elements, they are different for different elements. But there are some elements which have the same proton number but different neutron number. So atoms of such element with the same uh, proton number and the different neutron numbers are called isotopes. And because here the proton number is equal to the electron number, as you know, in the elements, so there are certain atoms or atoms of some element, you can say, have the different neutron number, and the proton number is same and electron number is same. So when the proton and electrons are same, electron determines the chemical properties mostly. So therefore we can say that isotopes have the similar properties, but they are different in the physical properties. Like carbon, it is having different isotopes. So you can see that the atomic mass is different. Like here it is 12, 13 and 14 for carbon, but the atomic number is remaining fixed, that is 6. So atomic number is same as number of proton, which is equal to the number of electrons are same. So you can say that there are variation is there in the number of neutrons, and that is not affecting the charge, because the neutrons, they don't have any charge, they are neutral. So there are certain examples like carbon. I told you it is having the three isotopes, carbon 12, 13 and 14, and in this the mass number carbon 12, that is the most abundant in nature. Then we have chlorine with two isotopes, that is chlorine 35 and chlorine 37, and the neutron number is going to change in all these cases, but not the proton and the electron number. You know that we calculate the neutron number by subtracting the atomic number from the atomic mass. So the atomic number for chlorine is 17. So proton number is 17, but neutron for chlorine and for chlorine 37, it will be 37 minus 17. And here the most abundant chlorine isotope is chlorine 35. It is more abundant than chlorine 37. And also we have hydrogen, which has three isotopes, that is protium, that is 1H1, deuterium 2H1 and tritium, that is 3H1. So the names are given to the isotope. So you can see in protium there is no neutron, because 1 minus 1 is 0, and then deuterium will have 2 minus 1 electron, that is 1 neutron and 1 electron, and in tritium the neutron number is going to be 3 minus 1. Also here the protium, that is the 1H1, is the most abundant of the three isotopes of hydrogen. Now going to the next concept, that is valency. In my last video I had explained you about how to draw the electronic configuration, and if you have not seen it, please go and check that out. The valency, when we talk about valency, there are different definitions that will be seen by you in different books by different people. The valency of an element is the number of hydrogen atoms that combine with or replace one atom of an element. So how many atoms are replaced by hydrogen, that is called as a valency. Also you will see that it is defined as the combining capacity of an atom. Also we can say it as the number of electrons which it's lost, gained or shared with one atom of the element in order to acquire the stable configuration of the nearest inert gas element. So what is this? You know that the last shell of the atom is a valence shell, and the electrons found in it is called the valence electron. So if you see here, you can see sodium atomic number is 11. So it is going to be, the electronic configuration is going to be 281. So that last one electron will be generally lost. So when that is lost, you can say when it will lose one electron, then it is going to have more protons rather than more electrons. So generally the valency of sodium becomes Na plus 1. Similarly you will see that for magnesium, where the atomic number is 12, we are having 2, 8, 2. So the last 2 is generally given so that the stable octet rule can be achieved, and the last shell will have 8 electrons. So atom generally is filled with the electrons, as you know, and it needs to be stable. So to become stable it generally donates or accepts the electron. So like in case of sodium, it will give that one to become 8, it will give this 2 in magnesium to become 8, but in chlorine it is 287. So generally it can take 1 easily, and here the electron number is going to increase, and when the electron number will increase, chlorine will have valency -1. Helium is having 2 in the last shell, and the last shell is a K shell in case of helium, and only helium can easily be satisfied with the duplet. It need not have 8, 2 is a satisfied condition for helium. And you know hydrogen, it is having 1, so generally it tries to take 1 so that it becomes duplet. And argon is another noble gas which is having 18 atomic number, so the position is 288. So 8 is already there, that is the octet rule is satisfied, and so it will not take or give any number of electrons. And hydrogen, as I told, it is the first element in the periodic table, and it is having 1 electron, so 1 valence electron in the K shell. So it's very reactive, and sometimes it's combining with all non-metals, and some metals it is also combining to form the compounds. So with this I'm very sure children now you have understood the concept of valency. You know how valencies are actually achieved, and also about isotopes. Don't forget to like and comment on the video. Thank you for watching.